There's a special type of ionic compound called hydrated ionic compounds, and these are ionic compounds that contain water molecules inside of the actual crystal structure of the formula unit. And so these water molecules are actually considered part of that formula unit. And we usually call that waters of hydration. So what does this look like? These would look like complexes that look like this. So for example, MgSO4 with 7 water molecules that go along with that formula unit. So again, these are integrated into the structure of this compound. And if we want to name this, we name the ionic part here the same way that we've already learned using our regular ionic naming conventions. So that would be magnesium sulfate. So notice that we have a polyatomic ion, which is specifically an oxyanion. It has that ATE ending. And then what do we do with that water? Well, we look at the number, and then we add hydrate, meaning water. So that number uses a prefix. So for 7, the prefix is hepta. Hydrate. So also notice that we have this dot here. That dot isn't a multiplication sign. It's just a dot that notates the fact that we have some waters of hydration in our formula unit. I've gotten people who answered naming questions on exams before saying something along the lines of magnesium sulfate times heptahydrate. We don't say that, we just say magnesium sulfate heptahydrate. Another example, here's one that uses a transition metal, so we can start practicing using those Roman numerals. COCl2 with 6 H2Os. So CO is cobalt. And cobalt is a transition metal, so we have to figure out what is the charge on that cobalt. We know that our Cl is a 1-, and there are 2 of them, which means that we're going to have 2-, which means the charge on our single cobalt has to be 2+ to balance out those 2-. So if we have 2+, that means that we have 2 in parentheses. Remember, it doesn't mean we have 2 cobalt atoms. It means that the charge on that one cobalt atom is 2+. So we have cobalt 2 chloride hexahydrate. So 6 waters, hexahydrate. So another one could be CaSO4 with 1/2 H2O. So does that mean we have half an H2O molecule? No, it doesn't. We already talked about that in a previous lesson, how we're never going to have like half of an atom in a compound. And if we were to split that in half, since there are only 3 atoms, that would mean somewhere there's going to be a fraction of an atom. And we know that's not possible. So what that really means is that for every H2O molecule that's integrated into that formula unit, there are going to be 2 molecules, or 2, units of CaSO4. But the way that we express that is for every CaSO4, we have half of an H2O. And the name of that would be calcium. Ca is calcium. Calcium is in group 2, so that does not have a Roman numeral. It always forms a 2+ charge. SO4 is sulfate. So calcium sulfate, and the prefix for 1/2 is hemi. So that would be hemihydrate. So the naming of these isn't too bad as long as you already know the ionic naming conventions. The only thing that might be a little bit different or unfamiliar to you might be some of these prefixes for the hydrates. So here are all the prefixes. You're going to want to memorize these. The one that might be unfamiliar to you is this one for 4. So one that you've probably heard for 4 in the past is quad. That's not the one that we usually use in chemistry. In chemistry, we usually say tetra. And then again, hemi is probably a new one. But the rest of them should be pretty familiar. So mono, di, tri, penta, hexa, hepta, octa, nona, deca. So those ones you may have come across in a prior math class before. But again, make sure you know these prefixes so that you can use them when naming hydrated ionic compounds.